Okay. Right, so what's f, or what's the letters here? What are the functions?
f is 2 plus 3x.
Okay, f is 2 plus 3x, like that?
Yeah.
Okay.
And the gx is minus x squared plus 2x minus 1.
Like this?
Yeah. And the h is 2 plus 9x over 3 plus 8x.
Yeah.
Yeah.
Like that?
Yeah.
And what do we want to calculate?
F, G, H.
X.
Want to calculate that?
Yeah.
Right, now hang on.
Yeah.
Okay, hang on. You tell me your answer. What did you get?
15 plus 100.
Hang on. 15 plus
102x plus 125x x squared over 9 plus 48x plus 64x squared.
like that. We want to see if these are the same.
Yeah.
I know how we'll do that. We can plot them. Right, that's the first one.
Yeah.
So when I plot this one, it should be the same.
Yeah.
Should be on top of it.
Yeah.
Let's see. Yeah.
Congratulations.
Congratulations to you. Good job. Good. Good. Okay, let's go on to the next lesson now.
So, in the test, if we write...
Of course, it's fine, yeah. Of course. Of course. Alright. Inverse next. Yeah. So, what the meaning is this. Ben, you ready? Yeah? Ben, ready?
Oh, yes.
So, suppose we have the function fx equals 3x. Okay, so it'll take x and you get 3x. That's function f. So for example, you're at 5 and you get 15. What we would like is a function to go backwards. Backwards. So we want a function so that if you were to put 15 in, your answer is 5. So what function would do that here? What function would you need to go backwards?
Or 5. Or, sorry.
X over 3.
Yeah.
If you have x over 3, then you go backwards. Okay, so the inverse function ff moves you back to x. Okay, so if you have x, you go over here to fx. If you were to calculate the inverse here, it should take you back to the x. Okay? So another way of saying it is like this. That f and f inverse, or inverse and f, they should both cancel. Now let's test it out. So let's do this example. F of x over 3. That's equal to 3 times x over 3, that's equal to x, isn't it? And what about the other one? F inverse of f. That's equal to 1 over 3 times 3x, that's also equal to x. And sometimes it's obvious what the inverse is. Let's do some obvious examples together. So, I'll write down the function, and you tell me what you think the inverse is. Okay, so x plus 1, what might the inverse be? How would you...
X
yeah.
plus 1. Oh, 1 over.
No.
Minus
Minus 1.
X minus 1.
1.
Yeah?
Yeah.
Yeah. 2x.
Negative x.
X over 2.
X over 2. Okay. E power x.
Log
Log x, good.
Yeah.
1 over x.
X. Long X.
1 over x.
Oh, it's like the
A little bit like the derivative, yeah.
yeah. Sorry.
You need to improve your English, Summer.
Sorry.
Sin x?
Cosine X.
No.
Tangent X.
No.
Minus cosine X.
No.
1 minus
Sine.
cosine
No.
squared.
Minus x.
English, you guys, you're English.
Sine
Sin inverse x.
Oh, it's inverse.
Oh.
Sin inverse x. Yeah? And x squared?
root
Yeah,
square.
that's-
Square root.
Square root x. Now, some of these are actually okay. So, this guy's okay, and this guy's okay, and this guy's okay, and this guy's okay. But actually, you have a little bit of a problem here with these ones. You might think this is the inverse, but it's not. Here's the problem. Suppose I have, well, here's firstly not a problem. Let's say I look at fx equals x squared, and f inverse x equals root x. Okay, so if I put in 2, what do I get if I apply f?
4.
4.
Oh.
Okay, fine. And f inverse of 4?
Minus
No, just 2.
Plus.
Just plus 2.
Yeah.
Minus and negative.
No,
No.
plus and minus. No. A function can only have one answer. Can't have two answers, you see. So here's the problem. If I start with minus 2, I go to 4,
Yeah.
but I go back to 2.
Yeah.
So this is the problem. F only has an inverse, F inverse, if and only if it is bijective. Now, do you remember what bijective means? You had that yesterday. In the last class. In the lesson on
Yeah.
types of mappings. Do you remember what bijective means?
Maybe I missed.
Did he miss? I don't think he missed this. He
No.
didn't. Maybe you didn't write it down.
Injective and surjective.
Yeah. And what was bijective?
Both of them.
Both of what?
Injective and
Yeah. So bijective means injective plus surjective. And what did injective mean? Injective, remember, meant 1, 1. And what did bijective or surjective mean? Huh? No.
On 2.
On 2, yes.
Oh.
So F only has an inverse if it's bijective. If it's not bijective, you can't find its inverse. Yeah?
What?
This function f is not bijective because it's not 1 to 1. You see, it takes 2 to 4 and it also takes minus 2 to 4. It's not 1, 1, is it? It's many 1. It must be 1, 1 to have an inverse.
So, F
Yeah?
minus 1 sine. It's not equals sine.
Yeah, no, but okay. The before I continue, you need to write this down. It's important.
Can you see the whole thing?
Yes.
Oh yes.
It makes sense for you, Ben?
Mm.
It makes sense?
Yx plus y is x.
What?
Huh?
To put this in this,
Yeah.
and you will get 1x
Yeah.
without nothing.
Watch. If I plus 1,
Mm.
then the opposite is minus 1.
Yes.
Yes. Right. Now, we noticed that there was a problem with sin x.
Oh yeah.
Because sin x
Cosine 2.
is not 1 to 1, is it? This is the problem.
Many to 1.
It's many to 1 because it looks like this.
Oh yeah.
If you draw a line here, it cuts it,
2.
well, actually more than 2, really, doesn't it?
Yeah.
Many times.
But if we get
Yeah, what we can do, so what you're trying to say, Ben, is we can make it 1 to 1
oh yeah.
if we restrict the domain. So if we make the domain smaller. So if you look at your graph, what would be a suitable domain? Well, you could go from here to here.
Yeah.
Because now we have only 1, and if we draw a vertical line, only 1.
Mm.
So you could say sin x to go from minus pi over 2 to pi over 2, that will go to 0, minus 1 to 1. Now this has an inverse. It has this inverse function, sine inverse, minus 1 to 1, back to minus pi over 2, pi over 2. So your calculator always gives you a sine inverse answer here. And let's take the other example. suppose I have the function fx equals x squared, and I want it to have an inverse. What would be a good domain I could use? Well, I could just go from
There are
0
also
infinity to 0 infinity.
Yeah.
And then f inverse would go backwards from 0 infinity to 0 infinity.
Yeah.
And here f inverse x equals square root x. But you had a second choice, or you could have said fx is x squared, okay? And f, we could say, goes from minus infinity to 0 to minus infinity to 0, and the inverse is the same. But in this one, you would use the function f inverse x equals minus root x. So you actually have two answers here that would work. Two possible answers. Yeah? Okay, do you need to write this one down?
Yeah.
You got that?
No.
Now? Ready?
Yeah.
Okay, so take an example like suppose you had a graph like this. Does this have an inverse?
No.
No. So if you wanted to have an inverse, you would have to restrict the domain. So you could go from, for example, here to here. Yeah? So you could use that part of the axis, and then you would continue from here. Okay? But don't use that height, because that's the same as that. And then continue here. So for example, if this, say, was 1 and this was 3, you could use the domain minus infinity to 1, and then 3 to infinity. But that's only one answer. You know, there's many answers. You could have done this. You could have looked here. And then down here.
Three answer.
There are many, many answers. You could have gone here. And then here. You know, there's many, many answers. Okay, many answers. Right. Now the big question is, how do we find the inverse? So for example, let's say I have a function like fx equals 2x plus 3 over x minus 1. And I want the inverse. Well, now it's not obvious, okay? So like here earlier we could kind of guess. It was easy. But now it's not easy. We need a way to calculate it. So I'll show you the steps. So step 1, yeah, you make y equal 2x plus 3 over x minus 1. Step 2, you get x. Okay, so that's yx minus y equals 2x plus 3. So that's yx minus 2x equals y plus 3. That's x, y minus 2 equals y plus 3. X equals y plus 3 over y minus 2. And then finally you swap x and y. So you say your answer is the inverse function is x plus 3 over x minus 2.
Oh. How?
How what?
Why the y become?
You don't have to, because the letter here is not important. You can use any letter. You could say t. It's not important, because if you calculate f and f inverse of x, it doesn't matter what letter I use here, because this is only to make the definition. The letter is not important.
Just to remember.
The letter's not.
Just remember.
Yeah, just to remember.
I don't know why.
No. It's
Why?
important. No, it's important.
So why we use y and get 3 steps and we can get this?
Okay. This here, 3x.
Yeah.
This here, 3y.
Yeah.
Are they the same or different? They're the same,
Yeah.
because f1 equals g1, f2 equals g2. The letter is not important. So
No,
just
no, I
oh.
don't say the letter.
Oh,
I just say why we use 3. You say.
3 steps.
Yeah.
Y plus 3 over y minus 2 is the inverse of the fx.
Ah,
Yeah.
that's a better question. Okay, so think about it like this. Okay, you have x, and then you apply some function f, and maybe it becomes 2x plus 3 equals some answer y. You want to go backwards. So you have the answer, y equals 2x plus 3, and you want to know what was the x that got you to the y.
Oh.
So you solve for x. You're working backwards. Here, look. Look. Summer.
Oh, yeah,
Look. Here is 4.
yeah.
Now, I use this function. Where do I go? I go to 11. I want to go back. So you need to say 11 was 2 times what plus 3? It must have been 4.
But
So if you can solve for x,
can we just go by
left,
the example?
yeah,
So what is the f minus inverse? F inverse.
f is x plus 3 over x minus 2. Watch. What?
No, I mean f inverse x.
Yeah,
Inverse.
inverse of this. Watch. What's f of 1? What's f of 1? Oh, sorry, not 1. 2. What's f of 2? What's f of 2?
7.
7, isn't it?
Yeah.
Right, let's calculate f inverse of 7. 7 plus 3?
What?
7 plus 3?
10.
10 over 7 minus 2?
5.
5 to 2.
See? 2 goes to 7, and 7 goes back to 2.
Oh. Nice.
Write this down. Okay?
Okay.
Now there is another way to calculate the inverse. Watch.
Oh,
Another way. Well, it works for simple problems. Like let's say I have fx equals 2x plus 3 over 4 as an example. Okay? You can think about it like this. You start with x. Then the first thing you do is you multiply by 2. Then what do? You add 3. Then what do?
4.
You divide by 4. So the inverse should be backwards. So let's say you start with x. Here you divide 4, so here you multiply 4. Here you add 3, so here you minus 3. Here you multiply 2, so here you divide 2. So this is the inverse. Let's check to see if it's right.
there you are.
So, f of 1, what will that equal? 5 over 4. F inverse of 5 over 4, that will equal 1.
Yeah.
Nice. Yeah?
Nice.
Last example. Can we use this method
No.
on this one?
No.
The answer is yes.
But you say it's simple.
Yeah. So watch the magic. I'll show you some magic now. Oh, I need space. Can you tell me what was the function? Fx equals 2.
2x plus 3 over x minus 1.
Okay, before I begin, I'll just rewrite this a little bit. X minus 1 divided into 2x plus 3. That's 2 times, yes? 2x minus 2, remainder 5. So I can write this as x minus 1 times 2 plus 5 over x minus 1. That's equal to 2 plus 5 over x minus 1. Okay, let's look at the steps. X. What do I do first? Minus 1. Now actually I'll make it even clearer. 2 plus 5 times 1 over x minus 1. Okay, so what do I do next? 1 over x minus 1. What do I do next? Multiply by 5. What do I do last? Plus 2. Let's try and go backwards. What's here? Minus 2. Divide by 5. 5 over x minus 2. And then here, 5 over x minus 2 plus 1. Now what answer did I get earlier? Where's my answer from earlier?
Is,
X plus 3 over x minus 2. Let's see if it's the same. So this is equal to 5 over x minus 2, x minus 2 over x minus 2. That's equal to x plus 3 over x minus 2. The same. Nice. I know. So don't do it this way. But I want to show you that you can get the same answer.
Can I?
In the exam, the best way to do it is this way for the exam.
If I use the other way.
Oh, you can use the other way. You mean like this?
Yeah.
Yeah, if it's simple. Okay, but in the exam you shouldn't do it this way. It's too hard. You want to write this down?
I only want
This one.
Up.
This one.
It's easy.
Oh, I keep forgetting. I need to do a lesson with you on graphs. The sine and cos graph. Because Joan didn't do that with you. No, I have to do it. It's important.
What's graph?
Sine and cos graph.
No problem.
Right. So what I want you to do, Marcus,
What?
you've still got 5 minutes left.
Yeah.
Yeah.
Oh. Yeah. So finish.
No, I want you to try some, then we finish. 5 minutes.
Okay.
That's all I want.
Okay.
Goodness sake. Right. ABC, 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 4, ABC. ABC, 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 4, ABC. What?
Family.
Yeah, finish it at home for homework. You can start now.
Okay. Thank you.
Is 6x minus 8?
Read the question. You have to say if...
That's the log.
No, don't. Summer. You have Summer.
Yeah.
You have to say if it has an inverse. Does 6x plus 8 have an inverse?
Oh yes.
Yes, it does. Does 2x
Oh.
squared?
Oh yes.
No. The second one is no.
Oh yes. Yeah, right. And yes. No.
Third one is no.
Why?
It's cubic.
Oh yes. Yeah.
Now, what you need to do...
Oh, I know.
Yeah, in question 2, what you have to do is restrict the domain to make it have an inverse. So, for example, in question A, you could just use x is more than 0.
Oh yes.
Yeah.
What? What's this?
Restrict.
Oh.
Look, I'll graph it. X squared minus 4.
Yeah.
Okay. Does this function have an inverse? No.
No.
Unless
0 to infinity.
that's the answer.
or
0 to infinity.
The second one.
Number
Second
2.
one Answer. Oh, okay. Oh.
Oh, second one. Oh my god.
Yeah. Here, I'll help you. I'll make the graph for you. What is it? 3 cos 7x plus 5 pi plus 7. Yeah?
Yeah.
Now, I'll teach you how to make these graphs later. What?
Oh.
But.
What? Ah. Yeah. So you could maybe use like here to here. Yeah. What's this height? This height is 4, isn't it? And this height here is 10. 11, is it? Yeah, no, 10. So, if you calculate the x for 10 and the x for 4, then you could use that answers.
It's x. It's y.
No, you need the domain.
Oh, so the next one.
Yeah, you have to draw it. You have to draw it.